I'm Anil Kumar, and in this video we will learn two different methods to find distance from a point to the plane. The question here is determine the shortest distance of the point P from the plane x minus 2y plus 2z equals to 3. The concept is that let's say we have a plane kind of like this and we have a point. If the point is external, we are finding the distance will be more than 0. If you have a point on the plane, distance will be 0, right? So let's say we have a point here. Let's call this point P. In that case, shortest distance should be along the normal, right? So it has to be along the normal. Correct. But to find the foot of the perpendicular is very difficult, so we select any other point Q on the plane so that we find this distance PQ and then take its component along. Let's say this point is O, then PO, which is D. The component of PQ along the normal is the shortest distance, right? So that is the concept, and that gives us one equation, which is shortest distance, which is always an absolute value, is the component of PQ along normal, which is the dot product. So it is PQ dot N divided by the magnitude of N, right? We don't want to multiply this with the magnitude of the normal, right? So that becomes one of the formulas. The other formulas is from the definition of the plane itself, that dot product gives you the plane. So the other formula which we can use is that the distance is equal to, whenever the equation is given in I should say scalar form or the Cartesian form, then the formula is that the absolute value, of course, a x0 plus b y0 plus c z0 plus d divided by a square plus b square plus c square, where we are taking a point P which is x0, y0, z0, and we are taking a plane which is ax plus by plus cz plus d equals to 0, right? So either of these formulas can be applied to solve such a question. So let's do with both. This is a very straightforward formula which can be applied. Let's start with that one. Now, to begin with, we need to find, we are already given the point P, right? So we are given the point P, which is 1, 2, minus 1, right? So I should say, now when I write like this, let me write vector OP. So from origin, let's say this is our origin also. So from origin, this becomes the position vector, right? Now let's take a point Q. Now to get a point Q, we are given the plane. So we can select some convenient values for x, y, and z to find x, right? So what we are given here is a plane. We normally write plane with symbols like pi. Let me write here pi, okay? And the equation of plane is x minus 2y plus 2z equals to 3. So to find a point Q, we can select values. So if I select y and z as 0, I get x as 3 to get an idea. So the point Q could be, I'm selecting these as zeros, right? So just for easy calculations. So I could write this as 3, 0, 0, right? So I've selected a point Q only for convenience. You could select any point. Since it satisfies this equation, it lies on the plane. That's the whole concept. 0, 0. So we get x equals to 3. Correct. Now, the vector OQ will be written like this, right? So, right, correct. Okay. So we have this vector OQ. So now what is PQ? So PQ will be OQ minus OP, correct? So I'm just taking time to do all this so that all understand what we're trying to do. So that means it is 3, 0, 0 take away 1, 2, minus 1, correct? And that gives you 3 take away 1 is 2, and this take away that minus 2 and 1. So that becomes PQ. Now we'll apply the formula and get the result. Okay, so PQ, so distance D is equals to PQ, which is 2 minus 2, 1 dot N for us is, you can read normal from this equation from the plane. So when you are given the plane here, these coefficients give you the N value. So let me write N as equal to 1 minus 2, 2, right? So that is the value of N. So N is 1 minus 2, 2. That is the dot product divided by the magnitude. So 1 square plus minus 2 square plus 2 square, square root. Now that is equals to 2 times 1 is 2, absolute value, correct. Minus 1 times minus 2 is plus 4, 1 times 2 is plus 2, right? Absolute value divided by square root of 1 plus 4 plus 4, that is square root of 9. And this gives you 2 plus 4, 6 plus 2, 8. Square root of 9 is 3. So you get 8 over 3 as the distance, correct? So that is how you can find the distance. Now let's do the alternate way of finding the distance, applying the formula straight away. So you found this, that's the right answer, okay? But it takes kind of time, especially when you know this, right? So D equals to absolute value. We'll substitute the given point P 1, 2, 3 in this equation. 1 for x, so we have 1 minus 2 times 2, right? And then we have plus 2 z. Z is minus 1. And we'll bring 3 to this side. So I should write this equation as x minus 2y plus 2z minus 3 equals to 0, right? So we get this, and minus 3 divided by square root of, same thing, right? That is the same, a square, b square, c square, which is actually the normal, right? So 1 square plus minus 2 square plus 2 square. And that gives you 1, 2 times 2 is 4, minus 4, and 2 times minus 1 is minus 2, and this is minus 3 divided by square root of 9. So that is, in the negatives we get 4 plus 2 6, minus 3, 9 and 1, so we get minus 8 over 3 absolute value, and that is equals to 8 over 3. Do you see that? So we get exactly the same answer. So the application of formula is much better in some cases. So you should accordingly work. I'm Anil Kumar, and I hope that helps. Thank you and all the best.